Hi, my name is Luke Stamp, and in this video I will show you why scientific notation is important, how to understand it, and how to construct and deconstruct it. So what is scientific notation anyways? Scientific notation is simply a more convenient way of writing numbers that are either very large or very small. Many of these numbers on the screen right now take a long time to be written and are hard to fully comprehend. By putting them in scientific notation, they are much easier to understand and can be used in calculations much better. It is extremely common in AP chemistry, and it's highly important that you fully understand this topic before moving on to more complex chemistry ideas. However, before you can learn how to form scientific notation, you must completely understand significant figures. Here's a quick review. All non-zero numbers are significant. All zeros before a number are not significant. Zeros between two non-zero numbers are significant. And trailing zeros count only if the number is a decimal, but they are not significant if the number is not. Now we can move to forming scientific notation. There are three main steps to forming scientific notation. First, you must determine the number of significant figures in that number and which specific digits are significant. Next, if the number is greater than 10, move the decimal to the left until there is only one non-zero number in front of it. If the number is less than 1, move the decimal to the right until there is similarly only one non-zero number preceding it. You should have formed a decimal somewhere between 1 and 10. Finally, report the answer as that decimal that you just found times 10 to the power of however many spaces you move that decimal. If you move the decimal to the left, the exponent is positive. If you moved it to the right, the exponent is negative. It's okay if you still don't completely understand this. I'll do some examples on the next slides. So here we have the number 2 million. We are asked to write it in scientific notation. The first thing to do is to find which digits are significant. In this case, the only significant figure is 2 because all trailing zeros are only significant following a decimal. Next, we have to create a single digit decimal, so we move the decimal 6 places to the left. We report the answer as 2 times 10 to the 6th power, which is much simpler. This question asks for 0.000320 in scientific notation. We find that the final three digits, 3, 2, and 0, are significant, so our final answer will be reported with these three significant figures. We move the decimal from where it is to 4 places to the right to create a number between 1 and 10. Finally, we report the answer as 3.20 times 10 to the negative 4th power. Remember that when we move the decimal to the right, the exponent is negative. Again, start by finding the number of significant figures in the number in decimal form. Since trailing zeros are significant following a decimal, there are 7 significant figures which will be represented in the final answer. Next, move the decimal 3 places to the right to create that number between 1 and 10. Report the answer with the correct number of significant figures times 10 to the negative 3rd power. It's also important to know how to go from scientific notation to decimal form. It's very easy though. All that you do is move the decimal however many spaces the exponent is. If the exponent is negative, move it to the left. If it is positive, move it to the right. The opposite of what we just did. For this problem, we simply move the decimal 8 digits to the left. Since the exponent is positive here, we do the opposite and move the decimal 8 digits to the right. For calculations involving scientific notation, the same rules that apply to significant figures apply. Calculations can be performed in either decimal form or scientific notation, whatever is easier for you. Just make sure to change the answer back to whatever form is most appropriate at the end. Thank you for watching, and good luck in AP Chemistry next year.